So today I'm going to show you how to solve a three-point problem. So to get the orientation. No? So in this map or geological map, first thing that you need to do is to find or identify uh, 3 points. It depends on the situation. But in here, we have contacts of our beds with different different elevations, so we can't solve it using the same elevation. So in this problem, we need to identify at least three points with different elevation to solve its orientation. So these are our geological contacts. So the first thing that we will need to do is to identify 3 points with different elevations. So in this contact, we have 600, is this one. Also in this one, we have 500, 400 rather, belongs to the 400. And our lowest elevation is 300. So these are the um, three points that we were able to identify. So what is the next thing to do is to connect all 3 points. So that is our 3 points. And the next thing that we will do now is to solve. So now we will do the solving. But before that, we will first use the scale given to convert it. So this is our scale, 0 to 500 meters. So in centimeters, it is 100 meters is at least 7 centimeters. So how will we solve that? So I'll fold this one. So first thing that we will solve is the highest to the lowest point, which is this one. So we'll draw our highest to lowest. So we will draw a right triangle over here, and we will put the highest point, which is 600 here, and the lowest is 300. After that, we will put a line on the center that represents the length of our middle line from this triangle. So it, it's like the length of this point onto the middle point over here. So the next thing we will do is subtract 600 to 300, the highest to the lowest, which is 300. Now, how will we solve the the angle of this triangle? So what we will do is first convert the length of the highest to lowest to its scale. So what does that mean? So first, we need to measure this length, and it is at least 10.4. 10.4. Or just 10.6. I'll just use 10.6 because it's my reference. But we need to convert the length of high to lowest to its scale. So what does that mean? The length of this in actual will be converted based on this scale. So our measured is 10.6 centimeters. We will convert that into its scale, which is 100 meters over 0.7 centimeters. Like that. Cancel, cancel. That gives us 1,413.33 meters. So I mean, in like if it's actual field, this is actually 1,413.33 meters. So after we get this value, we will now solve or we will now use this to get the angle. So what we will use is tangent theta is equivalent to opposite over adjacent, like this. So how will we identify the values? Tangent. What is our opposite? The opposite value of our angle is the 300, since it's the opposite of the angle, this one, 300, and the adjacent, which is this one, is this 1,413.33 meters. So basically, this line corresponds with this line. So this is the 10.6 centimeters or the 1,433 meters. Okay, so this is the adjacent, so we will put 1,400 meters. Now, when we use a calculator, the answer of that is, but first we need to transpose tangent over here, so it's tangent -1 to get theta. Meters. So the answer for that is 11.98 degrees. So let's recap on how to solve first for the first part. Since we have identified our triangle over here, or the three points rather, after that we will put a triangle like this, and this triangle represents this one, and to solve for it, we will put the highest point and the lowest point, and after that we will subtract to get the this value, the 300. And we also need to put this middle line, because that line represents our middle point, this one up to here. Okay, so now that we've got the angle, next thing that we will do is to solve using the highest to middle highest to the middle. So again, we'll draw another triangle. Now, what does that mean? So the next thing that we will solve is this one, the smaller triangle. So we need to draw another triangle over here. So our highest is 600 and our middle point is 400. Yeah. Notice that when we look at this, right, the angle here is just the same angle here. right? So we already have the angle over here, which is 11.98. So what will we solve here is the length of this one, this this line, this line. So how will we solve this? The thing that we will do is to get, for us to get the x is we will use still tangent, but since we have the angle, tangent 11.98 is equivalent to, what is our opposite? Our opposite is the difference of these two values. So we have 200. And since our adjacent side doesn't have any value, we'll use x first. So after that, we will cross multiply this one. Now that is done with cross multiplication, we will cancel this value to isolate the x. Do it also on the other side. So when we put that value in the calculator, we will get 942.54 meters. Since we already got this value, we will now convert the value of x in centimeters so that we can plot it on in our this one. So to convert it, 942.54 meters, 0.75 centimeters, 100 meters, we will get 7.07 centimeters. So now that we've got the length in the uh, for this solving, we will now plot the this value. So how will we plot this? The 7 centimeters is from the highest to the lowest. So how does that work? So we will measure 7 centimeters from the highest going to the lowest, which is here. Now, what will we do with this? When we get this length, we will connect this point from our middle to this one. So it looks like this. Now that you have generated this line, this is now your stripe. This is now your stripe. How will we get our true dip direction? To get that, we need to connect any point from this one that will connect to the highest point. But but always remember that it should be perpendicular. So what does that mean? We need to find a point from this area that when we will connect it to this side, or this point rather, it will be perpendicular. So for us to find that, we will estimate, we'll use the protractor so that we can find any point from this line that will connect from this highest elevation that has a 90 or perpendicular from this line. So if we will find, I think it's here, this line, we'll mark it here. If we connect those two lines, should be perpendicular, yeah. like that. So this is perpendicular. So now that automatically uh, helps us on identifying it, that our 2D direction may be over here or over here. Now, how will we get our true deep direction? We will base it on the elevation that it is given. So if we base our true deep direction from this side, it's wrong because the elevation from the contour lines is increasing. It should be decreasing. So we can now infer that our true deep direction should be on this side. So we will extend it a little bit. This serves as our true deep direction. Now, how will we solve for the true deep angle? So, for us to solve for the true deep angle, what we will do is to solve this one, solve this one. So, from our highest, we will measure this length. So let me do that first. So we will have our triangle. So we will have our highest point. We will need to have to use the middle value, the middle elevation for this. So 600 and our middle elevation is 400, so we'll have 200 because if we think this part is still the same as this one, so it should be 400. So we will use 400 for this one. Now, how do we solve for the angle? We will still use tangent. Theta is equal to opposite over adjacent. Now, how will we get the adjacent value over here? To get the adjacent value, this line represents this line, the length from this one generated strike to your highest. So if we measure that, that's at least 6.7. That's at, that's at least 6.7. So for us to get the value for 2 meters, we will first convert 6.7 centimeters to 100 meters over 0.7 centimeters. That gives us 893.33 meters. So we already have the value in meters. So we can now substitute this value to the adjacent. So our angle, we will transpose tangent here on the other side. So we have arctan or tangent -1 over our opposite is the difference of highest to middle, which is 200. And our adjacent is this value, since this represents this value. Now, what we will do next is put that values in the calculator and we will get 12.62 degrees. That is now our deep angle. So, final answer. So our deep angle is 12.62 degrees. Now, how will we know the direction of our strike. So from this one, we will create a we will create a Cartesian plane from this one. This is a small one. So we'll create a Cartesian plane from the intersection of your strike and your true deep direction. So for us to identify the strike, we will apply the right hand rule, which is this one. Where is our true deep direction? In this side, right? So our right hand rule should follow this. So what strike we will use? This one, which is the true deep direction is here, or this one, which is the true deep direction is this one. So we will follow this strike, not this one. We will use this because if we apply the right hand rule, it is dipping over here, not over here. So the strike that we will use is this one. So we will measure that. That's at least 70. So, so if that's 70, this is 70, that is so our strike is south 20 east. Since we've measured 70 here, we will always follow from south to east. So if this is 70, this is 20, then we will use 20, not 70. So it's like 20 degrees from south to east. So this is 20. So our answer is south 20 east, and is our deep direction is this one, which is should be southwest. One, two, three, four, five, six, 70. It 73. If this is 73, if this is 73, our direction is 73 southwest. So that is how we solve for the 3-point problem.